Okay, guys, we're moving forward. Let me try. I will try to keep my promise of making my chapters shorter. Let's see if I can do it. Let's see if I can stick to more or less my key topics, because I know that this hour everyone is tired, including myself, of course, but it's difficult. I know it's difficult. Okay, so the good thing is in our advantage is that a we got pretty nice chapters. You sure? You sure, Armando? I think it's on your end because the other ones can hear me. Yeah, it seems it is on your end. Yeah, reset as I had to do the other. Sometimes this happens, Armando. You know, sometimes you have to reset and start off from scratch. Imagine. Okay, guys, today we have a nice topic. Today we're gonna talk about the basics of matter and life, consequently. And I start my chapter with a statement that I have in my first chapter, that biology is the study of life, right? Biology is the study of life, and living organisms and their environments are subject to basic laws of physics and chemistry. We think most of us know that already. I don't see Crystal here today. You guys know Crystal? Okay, so I wanted to give this example because I suffered it. You know, this species here, is a species of ant that is introduced. It's an invasive species introduced here to the peninsula, and it has a pretty strong organic acid, formic acid. You cannot imagine how it is to be bitten by those uh, ants, because you don't get one to attack you, you get many, and then those ants can kill large animals. Don't think otherwise, because of this strong venom. It's one of the yes, Armando, but here they shouldn't be, and they are. So they were introduced. Sometimes it's people, sometimes it's trade, and so as a matter of fact, Jesus, we got a pretty long list of species that have been introduced from some other places. Of Cuba, of course, is pretty near, so we got many species from Cuba. But we also have species from South America, Asia, Africa, and some other countries. I don't think it's only Cuba or nearby countries. So I don't know what's going on. It's kind of slow today. Let me see if I can close down some things, because I always have many things opened. So organisms are composed of matter, and matter is defined, and this is one of my key topics for today, that as anything that takes up space and has mass. This is what we know of as matter. And matter is made up of elements of different type. You might remember from high school the periodic table of elements. I got just small bit here, not because it's one of my key topics, but because I have a good memory of it. This is one of the few things about chemistry that I liked. I don't like chemistry very much. I'm gonna be honest with you. Physics and math, on the other hand, I like a lot. Chemistry, not that much. And but the basics of chemistry, I like. And this is what we're doing today, because this is what we need to know to understand some of the other things that we're gonna be talking about biology, which is a subject, right? So you see, I'm gonna be letting you know which are the things that we actually need to know over the other ones. So I'm following up there. An element is a substance that cannot be broken down to other ones by chemical reactions. And a compound is a substance consisting of two or more elements in a determined ratio, right? So a compound, once you got more than one elements getting together, you got characteristics different from the original elements are reacting together, right? So like this. This is an example that is frequent, and it's one of the ones that I like to use. So you're gonna see it in some of my chapters. You see what I'm talking about? Does anyone know what I'm talking about? You know, when you put to react sodium with chlorine, what you got sodium chloride. You know what that means in human terms, in basic plain English? Salt. Yeah, it's a good example, guys. It is a good example because it's simple. Remember what I told you on the one. You know, um, I like to, I like simplicity. I'm a pretty simple man, and if you take a look at the project that I've done, you see that although you will see a lot of math and statistics, at the end, it's all pretty simple. You know, although I like numbers, it's not there is no contradiction between the fact that I like simple things, simple experiments, and simple projects, and that I use numbers. There is no contradiction. All right. So, so there are 118 elements that have been identified as existing on the Earth, of which the first 92 occur naturally, and the remaining are synthetic, and they are all contained in the periodic table. Let me see if I got it, because I got no, I took it out. I took it out. I got it in some PowerPoint, but you guys have to take chemistry, so I took it out because I know that you have to deal with it, study it in other classes. So around 20 to 25% of the 92 elements are essential to life and are called essential elements. Like carbon, you know, as I said, remember that I told you I was going to take out. I usually do that for different reasons. My chapter on carbon, because we're going to be talking about carbon-based elements, you know, all the whole semester. So you're going to have enough examples to see what I'm talking about. In life on Earth, guys, it's carbon-based. You know, carbon is a key element to life. When you see, you know, biological molecules, guys, biological molecules, I'm getting a bit ahead of myself, but it doesn't matter because we're going to get there eventually. Biological molecules are chains of carbon bound to hydrogen with other things that you see in the next chapters what the other things are. No, we're skipping that one, but you got it anyways in case you want to read it. So because this is it's kind of a repetition of the other things, and don't think I'm skipping it because we missed a class. I usually skip it. All right, I post it because I know that some people like to read more than others. So, but I sometimes replace that with some other things. So those elements like carbon, hydrogen, oxygen make up for 96% of living matter, and most of the remaining 4% consists of elements called trace elements that are not in a high amount, but regardless are pretty important, like calcium, phosphorus, potassium. It seems that magnesium is also important, right? And if you are in need, if you are tested for it and you don't have enough, going again a bit ahead of myself, guys, the um, the atom of magnesium is at the very core of the molecule of chlorophyll. So if you eat green, you are gonna get magnesium enough. All right. It seems that magnesium is more important than we thought it was. So I got some video. I watched some videos from some people, you know, authorities on the topic, saying that. So I'm not a biochemist, so I have to, I have to follow and believe what they say if they seem to say it honestly, right? So, well, here you got a table with a. And check out magnesium is the last one in the table, but it seems, as I said, that it's more important that we supposed we thought it was. So some elements can be toxic. For example, arsenic. But guys, you cannot imagine how living organisms, even pretty evolved living organisms like fish, adapt to arsenic. I remember I conducted a project once. It was 2008, I think, um, on an area, in a given area of a Central American country. I've done a lot of work. I told you at the beginning, I specialize on tropical biology, and I've done a lot of work in Central American countries. And one of the things that drew my attention at the moment was that the amount of arsenic in some lake there in the area that we were studying. And I said, this, considering this amount so above the threshold, you know, there should not be living organisms in that place. Totally the opposite. Many species, many individuals. Life is incredible. You cannot imagine how life adapts to different things like even arsenic. If you take a bit of it, you are gonna die. And some people adapt to it. Imagine some species, some living organisms. And the other example that I got here, it wasn't intentional, all right? It's serpentine soils, which is a specific type of soil rich in heavy metals. I said that only in a previous chapter, and you can tell because these type of soils are rich in rocks that are grayish. So when you see that, you have to immediately think that you are in a place that serpentine soils prevail. And this is a good place to extract metals like nickel and some related ones, like the one that I mentioned in my previous chapter, in my previous lecture. So it seems that the plants develop certain adaptations, like the one that I mentioned that I accidentally came across. Remember the hair on the leaves? I wasn't looking for it. I was basically supervising a group of people doing an assessment, making sure that they were doing the right things, and then I saw it. I said, "What is this?" Because I was familiar with the species in other places. Check this out. This is what I'm talking about. This is the hair I'm talking about. No, actually, if I don't talk about it directly in my in my classes, it's not going to be in the test. It's going to be in the test, of course, but through other chapters, because as I said, carbon is a crucial element for life, right? So, so we're going to talk about carbon anyways. In other words, Crystal, you here today. You made it. Can you hear me? Crystal, can you hear me? Are you here? Are you there? Thank you. And so I think the thing is that I saw Crystal joining, and I wanted to ask her if I answer all her emails. She sent some emails, and I'm not you know, I do not check my, and as guys, by the way, I said this at the beginning. I want to repeat it because I don't want you to get frustrated. I do not check out my, I'm pretty busy. I don't do it. I mean, I'm always kind of busy, and I don't check my MDC email on a regular basis. So if you guys want a quick answer, please send or copy at least my Gmail, all right? Which is the one that I got in my cell phone that I can answer when when I'm in the parking lot, or when I'm in my office or somewhere, all right? Chris, are you there? I saw it joining, but okay. So moving forward, guys, matter, the smallest unit of matter is called the atom. And you may think this is a recent discovery, but it's not. The atom was introduced to science by Greek philosopher Democritus. And I don't know what these guys ate back in the day that they were able to produce these ideas. It is so amazing. I don't know what they ate. This is Democritus, Plato you know with this idea. It's not far from reality, right? That matter was made up of four elements and all that. So this guy was so brilliant. I never cease to amaze about it. So yes, Jesus, it is what it is. We imagine that you left alone for a couple of years thinking, without knowing this. I don't think I would be able to come up with the idea that matter is made up of atoms. I wouldn't. I'm being honest with you. I've gotten some good ideas in my life, but this is so so specific, so into detail. All right. So atoms are composed of three basic particles: neutrons, protons, electrons. Neutrons have no charge, protons have a positive charge, and electrons have a negative charge. Let's see how they are placed in the atom. And one thing that I don't like is that in order to move to to advance forward, I have to click down here. I cannot click somewhere else. So sometimes I lose my cursor. I don't know what it is. So neutrons and protons are located in the atomic nucleus, and electrons are basically spinning around. Sometimes different atoms have, and some atoms have one level, you know, called layer or shell. Sometimes they have more, right? Sometimes they have more. Oh, you see one here with one, right? This is the nucleus with the protons and neutrons, and electrons are spinning around them. And this particular one has one layer or shell. I don't know, guys, for some reason, at some point, like 1 year ago, I lost, back in the day, my students were able to see my cursor moving. So I was able to point at things. And now I have to, for example, if I want to point at some, I have to make a drawing because my students cannot see my cursor. I don't know what happened. I did nothing wrong, let me tell you. So I don't know. I think it was on the other end, on Blackboard's end. Okay. So atoms of the various elements differ in number of subatomic particles. So an element's atomic number is the number of protons. So remember, this is a review. Some of you, I'm sure, know about this because this is chemistry, and you have to take it. So this is a review of things that you should know. If you do not remember for some reason, that's fine with me, as long as you activate these memories today, all right? It's a good question, Armando. I remember that word back in the day. I think it was in the previous century, if I remember well. Yeah, I used to pay attention to that type of things, when I was watching science fiction movies and stuff like that. It was in my early stage, when I was a pretty advanced biology student. But then when I became a professional, started working, and I focused on what I had to do, stopped having time to read about things like that that are pretty interesting, by the way. It's not like it's not important. Sometimes you have to. This life is a trade-off. There are things that you want and like that you cannot do, and that there are things that you don't like that much that you have to do. For example, one of the things that I don't like to do, Armando, is to go to meetings because they're usually, let me tell you guys, you may agree or disagree with me, but for me, it's usually a waste of my time. But I have to do it. Imagine, and I cannot read about quarks, so it is what it is. So an element's mass number is the sum of protons plus neutrons in the nucleus. And atomic mass is approximated by mass number, right? So basically what we have to know is atomic number, mass number, right? These are most of the things, guys, are key topics because this is like, the basement or the whole building of matter and life, right? Then in other topics, you see that we're gonna point at some specific things, which are the ones that are gonna be my key topics, because in those chapters we're gonna be talking about other things more advanced. But this is kind of basic, right? So, and an interesting topic to talk about, guys, is isotopes. It brings good memories to me as well. I'm gonna try to be brief and give you an example of why I wanted to work with isotopes back in the day. Isotopes are atoms of the same element that differ in neutron number, in the number of neutrons. And the thing is that many of them are radioactive. I don't know if all, but most, I think. So they decay spontaneously and they give off particles, a fact that we take advantage of to do different things. For example, we use that fact to use them as radioactive tracers to detect different issues that we may have in medicine, for example, like this. You see, there's a problem there. You use an isotope, you tag the problem, right? Whatever it is, cancer or whatever, and then you see it. Then you can follow, you can monitor what's going on. All right, that is the point. And also closer to what I do, because I not do by biology related, I mean medicine related biology. What I do is more environmental. The other things that we do is radiometric dating. We use isotopes to date fossils. Fossils are rocks, right? Are rocks. So we use these isotopes to date these rocks to see how old they are. So back in the day, you need to basically guess the how old they were based on the layer of substrate that were found. Now you can tell. Now you can assign a real date to them. Okay, so um, and my example was on the following um, topic. The example I was going to give you is related to animals. So one of my lines of work was because I've done always two or three things at the same time, and one of the things that I did for many years, and eventually led to my doctorate thesis, was the study of invertebrate animals, and with an emphasis on mollusks, land snails, and related. And the thing is that some of the I think this applies for most land snails. They disappear in summer. Things get so dry in summer that in some part of the summer, because at different points of the summer it rains, But when it's not raining, it gets so dry, the soil, that they disappear because they require humidity to thrive, you know. So I said to myself, I think a good way of finding where they are, because they should be hidden, because when it starts raining, they appear sort of out of the blue. I said to myself, I think if I tag these animals with isotopes, I'm going to be able to find them in the wild. And I started sending out letters because you cannot use them like for free. You know, you need to have permissions and stuff. You know how it is. But nobody answered. I mean, I got like an answer, like a vague answer from someone, like months after. So at some point I quit. I said no, I'm gonna do other things because it's sometimes for some things it's so difficult to get permission that I quit thinking about it. I said, let somebody else do it. You know, I was so excited about it. Okay, so moving forward, we're gonna introduce here the concept of energy. We're gonna go back to it in a chapter that we have to discuss like basic principles of biophysics. Like class of biology, guys, comprises elements from other classes like chemistry, which is this one, and biophysics and cell biology and biochemistry and genetics and all that. And then the following one, the bio 2, contains elements of evolution, zoology, bacteriology, and different other things. So basically, energy is the capacity to cause change, and potential energy is the energy stored. So the electrons of an atom differ in their amounts of potential energy. That's the point, right? That's the point. So the chemical behavior of an atom is determined by the distribution of electrons in electron shells. Remember, layers of shells, right? When the places of the atom where they spin around the nucleus. So the periodic table of the element shows the electron distribution for each element. And this is just a section of it, right? Just a section. We don't need more. And this is just what we actually kind of need to know, which is atomic number and atomic mass, as I said earlier. All right, atomic number, number of protons, atomic mass, which is the summation of both protons, neutrons. And then this is also important to know, valence electrons. Why? Because these are the ones located in the outermost layer or shell, right? And consequently are the ones that are going to be part of bonds. And bonds we care about because we are here, guys. We are organized, as you can see, instead of see like a cloud of of atoms and molecules moving around. When you look at your laptop, you see me. If I look in your direction, I'm going to see clear faces because you guys are organized matter, you know, and this is because of bonds, because of the bonds that hold the molecules of what we are together, you know. That's the point. That's why bonds are so important and consequently are one of our key topics for today. And this is our the starting point of our talk on bonds. So atoms with incomplete valence shells can share or transfer, depending on the type of bond, valence electrons with certain other atoms. You know, when two atoms get together, we get a molecule, right? At least we need at least two atoms, even from the same element, to form a molecule. So these interactions usually result in atoms staying close together, held by attractions called chemical bonds. We got 10 types. We're going to be talking about these three different types. Starting with covalent bonds. We got covalent bonds, we got ionic bonds, we got hydrogen bonds, right? Hydrogen bonds are weak bonds, but crucial, important, of paramount importance for life. You'll see why. So a covalent bond is a sharing of a pair of valence electrons. At the end, everything takes place between valence electrons, the one in the outermost layer of shell, right? They share, they get together and share, right? Is a type of bond where where electrons are shared, right? So they count as part of each atom's valence shell, as if they were like um, living, sort of living together, but in a slightly different way, as in the other case, the case of the ionic bonds. Here you got the formation of a bond, okay, between, in this case, two of the same, two hydrogen atoms that form together a molecule. Well, this is what I said, and so single covalent bond or single bond is the sharing of one pair of valence electrons. So a double covalent bond or double bond is the sharing of two pairs of valence electrons. And we'll see in the next chapter, when we do biological molecules, you see how important it is, mostly for one of the types of biological molecules, lipids. You see how important it is to have single bonds versus double bonds. All right? This is what bonds are so important, guys. Apart from the fact that I told you earlier that if it wasn't for bonds, if it wasn't for how strong bonds are, we wouldn't look like the way we look. You know, we would look as if you were like, you know, looking through glasses that don't have the right measure. You know, you would look like kind of blurry. Okay, questions, comments, anyone? Viviana, you're quiet today. I saw you here. You haven't posted any question today. Is that a good sign?
No
That you haven't
questions
posted
so
question?
far, Professor.
Okay. Okay. If you say so, remember, as I like to repeat, as my professor of physiology once told me, silence is information. Maybe not a good type of information, right? Because when people silence, I get like, are they following? Are they not? Okay. So what these are the different types of formulas for the different molecules, right? But this is basically for formative purposes. And you got here a table with different examples on key molecules like oxygen, hydrogen, water, methane. Guys, methane is important in a bad way. You know, it's one of the worst greenhouse gases. I don't know if you knew that. You guys knew that? Jesus, do you know that? That methane is bad? Anyone?
Yes.
Okay. Do you know? Do you guys know how this molecule is produced? Out of what? Yes, you're totally right, Jesus. Totally right. So, Jesus, you know, let's work on killing cattle to reduce methane emissions. Will you sign up for that? I don't. Me neither. Yes, guys. You know, I like meat. I won't lie to you. You know, I'm aware that methane is bad and is produced by cattle, you know, cows and bulls and all those guys. But good point. Good point. It's exactly what I say. It is important to sustain, to feed the population. You're totally right. So you know what people are doing, what science is doing, Jesus, to try to, maybe not to prevent, because it's difficult to prevent, to reduce the amount of methane that is emitted to the atmosphere by these guys. I know. But you know what the scientific community is doing, Jesus? What, would you like to know what the scientific community is doing? Okay. So they are creating modified species of grass pasture, you know, that when cattle eat them, produce lower amounts of methane. This is the way we are fighting that. I don't. I know that there's some friends of mine, some colleagues of mine, yeah, yes, it's a wow, yes. Some colleagues of mine are working on it, and it's working. So when you compare, you get a group of animals, you feed them with regular grass, regular pasture, natural, and then you compare that, the amount of methane that is produced with what they produce when they are fed with all the type, the GMO one is, I don't not remember. I used to have the amount, but I think it's kind of is around half of it, so it reduces a lot. This is it's a big deal. Some people, guys, are against. I'm gonna be talking about this more at the end of the course because I got a topic where this point is pertaining. This is not that important at this point, but some people are against GMOs. I think we need them. It's like a necessary evil, let's say. You know, I know that there are different challenges that GMOs, and talking about genetically modified organisms, in case you don't know the acronym, I think it's a necessary evil, guys. It is what it is. We have to use them because, quoting Jesus, we need to sustain the population. And one of the things that we do with those GMOs is to have, for example, bigger things, like, guys, I've seen pumpkins this big. If you see something like that's not natural. Absolutely. You see pumpkins like this, tomatoes like this, that look like almost like a pumpkin, you know. So, and they serve a purpose. They are used here in the U.S. where they are necessary, but they are even more necessary in places like India. How can those guys feed their population without GMOs? No way. So they need it. They need, believe me, guys. Believe me. Some people have like a crazy fight against GMOs. I think we have to coexist with them. It is what it is. It is what it is. Okay. So covalent bonds. Well, it's in the structure of the molecule, Lewis. So there is a balance, and they have to be balanced out. Remember, all molecules should be balanced out in order to be in equilibrium. And some have more, some have less. So it is what it is. I couldn't give you like a more accurate answer because from my point of view as a biologist, this is what I know about chemistry. It's not that I was a bad student, let me tell you. The fact that I don't like chemistry is that much doesn't that I was not a good student. I was a good student, but it's not one of the things that I enjoy going to. For example, I enjoy a lot going to classes of math. Absolutely, absolutely. But that is at the end the balance of the equation. When they get together. Yes, absolutely. So following up with covalent bonds, let me tell you one thing that is important to know. Covalent bonds are the ones present in organic molecules. All right. And we are going to be talking mostly about organic molecules, not inorganic. So this is the science of organic molecules. So basically, all the examples of molecules that you're going to be seeing from next chapter on, it's organic molecules. Oh, well, this is what they are doing here, Louis, is to represent what they are graphing the different ways that you can use to represent the formulas for the different um, molecules. This is the point for this table, right? In different ways of representing the structure of different molecules. As you can see, they have the was the term. They have the spatial model here on the right. You know, they have the formula here. They have the other formula here on the left. They have the approach, the atomic approach here to see, you know, how the bond is formed. So the different ways of representing the same, basically. So um, so covalent bonds can form between atoms of the same element or atoms of different elements, as I said earlier, right? So a compound is a combination of two or more different ones. If you say, if you hear the word compound, it's because it's different. So when I skip things, it means that it's not that important, all right? So atoms in a molecule attract electrons to varying degrees. And there is one thing that takes care of that, which is electronegativity. That is an atom's attraction for the electrons of in a covalent bond, right? In a covalent bond. So the more electronegative an atom, the more strongly it pulls shared electrons toward itself, right? So it's all based on that. Bonds and electronegativity. It's all based on that. And one that we cannot forget, apart from the fact that this happens, bonds happen due to electronegativity, there is one thing that is as important or even more, which is that there are two different types of covalent bonds. We're going to pick this up on the next chapter, right, where we're going to discuss water, or yes, I wasn't being accurate. I said we were going to talk about the molecules of life, but it's not that. We're going to be talking about water next time we meet, and then on Thursday we're going to be talking about the molecules of life. First comes water. I got pretty cool examples about water, the different properties of water, and always with my examples there, you know, because I like to think this class is biology, so I keep the chemical approach, but I include examples from biology. So what does it mean, these non-polar polar covalent bonds? So from the chemical point of view, atoms that share electrons equally, they is not remain in charge, so they are called non-polar. Polar, on the other hand, is when there is a remaining charge, right? There is more negative on one end, more positive on the other end. Those are polar. In practical terms, guys, polar means, is everyone paying attention? Viviana, you there?
Yes.
Still
Yes.
with me?
Yes.
Yes.
Good. So polar means, guys, being able to dissolve in water. Non-polar, being unable to dissolve in water, or being able to dissolve in oil or oil related. You see what I mean? The all relation between water and oil, right? This is what it means. Are we good? It's as simple as that. Example from real life. Does anyone here takes the trouble of going down to a place called, you guys know there's a place called Home Depot? You guys know that?
Yeah.
Yes.
Good. Well, they sell different things there. I like it. I have to say that I like it. You know, I mean, I don't like the place. I like the things they sell there. And I used to do, not anymore. Now I pay for that, not because I don't like to do it, but because I don't have time to do it. I have to pay for people to come over and paint my walls every now and then, because we are careful, and sometimes we paint the walls and it lasts for years. But if you want to do it, guys, there are two different types of paint, you know, water-based and oil-based. Do you know that?
Yes.
Yes.
Good. That
Yes.
is a pretty bit. That is a pretty important bit of knowledge, you know, knowing that, because back in the day, back in the day, if you wanted a good paint, you needed. Well, it's not bad. It's not bad. As a matter of fact, Armando, I remember having a student of mine in the Westchester Home Depot, and I used to go there with him because he was able to give me discounts. and advice and all that, it wasn't bad. It's I think it's one of the jobs that one of those jobs that you gotta have when you're a student. That is not it's not one of the bad ones. I think. So the thing is that back in the day, let me tell you this, because this is you won't hear this from everyone. If you wanted a good paint, you needed to buy some that was oil based. Not anymore. Now, like, I think it started off like 20 years ago. You buy some that is water based, and you can get great paints. So what the advantages of using a polar or high water based paint, that you do
No.
the painting. When I do that, I get covered. You know, I put more on me that on the walls. And then back in the day when I was doing the no-polar thing, I had to use exactly that's the disadvantage. But in order to remove that from your body, you need to use this solvent, which is a related compound or gasoline, something like that. You need to use something like that. You need to use a piece of clothing and start, rubbing your skin and all that. If it is water-based paint, you just open the faucet and it goes off, and you get the same quality of paint in your wall. That's the point. That's why it is so important to come to my class, because you are going to learn about things that are biology, but also you are going to find an application to that. It's a good comment, let me tell you. It's good that you share that with the other guys. Whatever type of things that you have like that, share. I don't mind. Okay, so ionic bonds. Guys, pay attention, because this is the first and the last moment I'm going to be talking about ionic bonds, because remember, the point for my course is covalent bonds, not ionic, all right? This is for inorganic. This is the type of bond present in organic compounds. So sometimes some atoms strip electrons from the partners with which they form a molecule. So an example of the transfer of an electron is the transfer of an electron from sodium to chlorine. Imagine the always the same one. So after the transfer of an electron, both atoms get charges, and if you get different charges on both ends, they attract. Similar charges repel, different attract. And this is what happens here. And through this process, remember what we said at the beginning, all of us, because you guys knew that well. Sodium chloride is formed. First this electron is taken from the chlorine atom, and then when that happens, they get a charge, the other one gets a charge, and they get together. It's a different type of bond compared to the other one, compared to covalent. And let me show you some examples. I won't give you guys examples on covalent bonds, because you are going to have plenty of them during the semester. So you don't need more. We're going to be talking about lipids and nucleic acids and proteins and all of it. All right. So a cation is a positively charged ion. An anion is a negatively charged ion. And an ionic bond is an attraction between an ion and a cation. A molecule with or an atom with a positive charge and another one with a negative charge. That's it. And here you got my examples. Well, this is not my examples. Neither is this. These are my examples. Check this out. Guys, I could have given you any examples. It doesn't have to be these particular ones, but I wanted to use this one. First of all, because as I told you, I like, snails. And this particular one, I don't like. Why? Because you're going to be wondering why. This is the African land snail. It's an invasive species. And guys, it's like this. It's pretty big, and it eats everything. It was introduced to the state because we get visitors from everywhere, humans, plants, and animals, right? And sometimes they get overlooked. And there was an invasion of those guys, and they assigned a lot of resources from the state and from the federal government to try to eliminate that. They say, I do not, I do not believe that's right. That's accurate. They have it controlled. They said that. Yes, that's what I'm saying. But they say they have it controlled. Not so sure. This type of species, if there is a, is an, if you leave behind an egg, it never ends. You know, once it's introduced, maybe you have it controlled in the sense that you don't have like major populations of it, but getting it extinct is difficult. Getting rid of it, difficult. So the thing is that I wanted to give you guys calcium carbonate as an example of an inorganic, because it's difficult. It's difficult. When life is introduced in a given place, it finds the way. It finds the way through. Louis, if there is a remaining, imagine. Sometimes I've seen introduced animals are able to survive in an almost man-made place, like a park. Imagine in a regular wild place how many places to hide they have. It's difficult. It's difficult to find them all, or to find the eggs and get rid of them. It's difficult. It's very once it's introduced, it's difficult to totally get rid of it. You can get it controlled. You can lower the populations to decent levels so it doesn't make an effect on the local agriculture and all that. You can do that, but getting rid of it, well, let's see what happens in the near future. Okay, so what I was saying is that the shell of the snails and of other snails, not only this land snail, but also marine and freshwater, and also the skeleton of corals is made up of calcium carbonate. So it's a pretty important inorganic molecules, and inorganic molecules are held together by ionic bonds. I wanted to give you this molecule here because back in the day, it was widely used, as a matter of fact, as to control, as a chemical control to land snails. Again, table salt, also potassium hydroxide, that is used to make some soaps and also for cleaning purposes. And citrate, I don't know why I gave you this, but it's an example as any other. I just wanted to give you examples, and when you compare this with organic molecules, you see how different they are from this, right? That's the point. Okay. So my final type of bonds, weak chemical bonds. I won't reveal a good example. I'm going to save that example for next week. An example of a molecule where weak bonds, where hydrogen bonds are present. So most of the strongest bonds in organisms are covalent bonds that form a cell's molecules. So weak chemical bonds are also indispensable. You'll see how indispensable they are. So many large biological molecules are held in their functional form by weak bonds. So the reversibility of weak bonds can be an advantage. For example, the example that I'm going to give you today, well, a hydrogen bond forms when a hydrogen atom covalently bonded to one electronegative atom is also attracted to another one. So in living cells, the electronegative partners are usually oxygen or nitrogen atoms. I won't say specifically what type of molecules we're talking about. But my example for today, just to give you a heads up of how important these guys are, is water. What what can we do without it? Nothing. Water is crucial for life. And let me give you this image, this visual image for you to put it in your mind and work with it. You guys are used to having rivers and seas and oceans of water, right? And water has these, the atoms of water are held together by hydrogen bonds. That is why they are able to break off and reform immediately, like this. See what I'm holding in my hand? When with this movement, they are broken off and then they reform. They go back to the previous stage. But imagine that water, that hydrogen and oxygen were held together by, or were bound together by covalent bonds. Can you imagine that? Let me give you an example. It would be more or less, you know, as if they were, as if you were looking at condensed milk. You know what it is? You know what is that? Condensed milk. It's a type of milk,
Yes.
dense, sweet, that comes in cans. Can you guys imagine? Have you guys taken those cruises out to the Bahamas and to the Caribbean? Does anyone
Yeah.
have taken that? Okay. So can you picture yourself sailing out in a sea of condensed milk instead of water? It tastes good. I give you that. Well,
It's too
Louis,
thick.
you will love it.
Way
You
too
will
thick.
love it, but it would be difficult to sail in a sea like that, because it would be so dense that it would be difficult to sail out in that type of sea. Keep that, keep that in mind. That would be hard. Exactly, actually. That would be very difficult. That is why, guys, instead of having covalent bonds, check out, these are the magics. These are the wonders of life. Instead of having covalent bonds, we got hydrogen bonds instead. All right? So I'm not gonna mention the other example. I'm gonna save that for my chapters of the next week. So my final comment for today, I'm trying to make an you saw I'm trying to make an effort to make it shorter. Is this is not one of my key topics, but I want to say it anyways because I like it. Okay, and I'm talking about van der Waals interactions. This is not pure chemistry. This is a blend of chemistry and physics. All right. So if electrons are distributed asymmetrically in molecules or atoms, they may accumulate by chance. So yes, sort of, yes, Henry. They may accumulate by chance in one part of a molecule. So these attractions, they are named after the biologists who discovered that. And attractions between molecules that are close together as a result of these charges. So collectively, such interactions can be strong as between molecules of a gecko's toe hairs. And that's what I like it. That is what I like. I don't mind. I don't care about the van der Waals interaction if it wasn't. I wouldn't care about them if it wasn't, because they are the ones in charge of making possible that these guys that I like can walk on the walls. Geckos. You guys like geckos?
Yeah,
Anyone?
geckos are pretty cool.
They are cool. But not only that, guys, if you see one, sometimes they'll fall off from the wall or the ceiling. Do not step on them. Do not kill them. They are working for us. They eat roaches, they eat ants, they eat things that are not good to us. Do not kill them, all right? If you find in your household, let me say this. This is infrequent, but it may happen. Maybe a bat gets into your household and tries to start a nest there. Take it out, push it out, don't kill it. You cannot live with a bat, but you should not kill it because it's not bat with a D. A bat with a T is not bad with a D. They do good things for us. So push it out, push it away, but do not kill it. Same for these guys. They are, I know they are not that good looking, but they are good for us. They work for us. Eating those things that we don't like. And this is just context, just to say who this scientist was. Whenever you see Van der Van X or Y, it's Deutsch, right? It's Deutsch. Okay, and these are my key topics for today. It's been slow. I don't know why. It seems that my internet connection is working. It's not working right today because I got most of the things that I had opened, I got closed. Comments, questions, anyone? Thoughts? Chriselle, you there?
Okay.
Chriselle, you there?
Yes, sir. Yes,
I
yes,
mean,
Professor. I'm here.
oh,
Yeah,
okay,
I'm here. I'm here.
okay, okay. Because the thing is, I wanted to ask you if I answer all your emails. You sent me some emails. I think I answered some. Not sure whether I answered all of them. Right?
Yeah. They're all good.
Okay. So yes, you do. Unfortunately, Jesus, you do. That's why I don't have that that good feeling towards chemistry. You know, because you know why, Jesus? Because I had to take a lot of them. You know, general chemistry, organic chemistry, biochemistry, physical chemistry. I got like tired. We had chemistry from so many different angles that I actually got tired, guys. Let me tell you. But it's important. It is important. We need to know chemistry. It is what it is. It's a science. It's important to understand biology. I know. I think that's one of the issues that we have. Today, my current boss told me. I told him that I was gonna try to get what's the word, accredited to teach biostatistics because I did it for many years. And here there is one thing, I don't know if you guys know, there's one thing called SACS, because of which I cannot teach biostatistics.